All right, so this is page 17 as a warm-up. Today we're going to focus on learning about the binomial theorem. This is not on the quiz, the theorem, but page 17 is a perfect quiz review for tomorrow. So we're going to pause the video to give you time to do it, and then you can watch the solutions. Planting a garden, there are 3 kinds of flowers in 4 colors. So the counting principle, we're going to do 3 flowers times 4 colors. That is 12 outcomes. So for a tree diagram, it's going to be roses, zinnias, and cosmos. And then for all of these, we're going to do the 4 colors. So yellow, red, orange, purple. Yellow, red, orange, purple. Yellow, red, orange, purple. So then the sample space, oh, it's gonna be a long, we have to list all 12, is gonna be rose yellow, rose red, rose orange, and rose purple. And then zinnias yellow, zinnias red, zinnias orange, zinnias purple. And I'm gonna go up here so I don't take up space for these. Cosmos yellow, cosmos red, cosmos orange. I didn't even spell that right. There we go. Cosmos purple. Probability that a yellow flower is chosen. So you can either look at your tree diagram or the sample space. This is a little neater. So there's 1, 2, 3 yellows out of 12 outcomes. A zinnia, so there's this branch, but there's 4 colors of them. So that is 4 out of 12. And don't bother to reduce, just leave the fractions the way they are. And a red rose, that only happens once, so that's 1 out of 12. 8 children stand in line to play a game. How many ways can the children be arranged? So order does matter. So we could do 8 permutation 8. Or since there's just the ways for them to be arranged, we could do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 8 factorial. You need a calculator for the quiz. So let's see. 8 math, probability number 4 is factorial. Or I could do 8 math NPR 8 and see how it's the same value. So this equals 40,320 ways. Okay, license plates are 2 letters followed by 3 numbers. If repeated letters and numbers are allowed. So we've got 2 letters and then 3 numbers. So 26 letters, 26 letters, 10 digits, 10 digits, 10 digits, and we're gonna multiply. $676,000. Now, if they cannot be repeated, it's 26 letters and then 25 letters, 10 digits, then 9, then 8. It's annoying. We're gonna try it this way. $468,000. A specific program requires the user to enter 5 alpha-based password. The letters cannot be repeated and can be any of the 5 letters listed here. How many different passwords are possible? So 1, 2, 3, 4, 5, 6, 7 letter choices. We need 5, and order does matter, so it's a permutation. So 2,520 passwords. Okay. On page 18. This symbol, these vertical brackets with the NR, stands for the combination. So here in A, we've got 3, 1. So that is 3 combination 1. Or you can write out the formula this way as 3 factorial over 1 factorial times 3 minus 1 factorial. But that's a lot longer, so I'm just going to go over to the PRB menu, use choice 3, and that is 3. We can do the same thing here. Six, and here, 8. Oh, you can't see that. So these numbers are not just random numbers. They do come from a pattern called the Pascal's triangle. And the way we build Pascal's triangles, we start with 3 1s. And the 1s go down the sides. And when you add these ones up, you get 2. When you add 1 and 2, you get 3. 2 and 1, you get 3. And the wait, it keeps going. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 and 6 is 10. And then notice the symmetry. If we draw that vertical line down the middle of Pascal's triangle, it is symmetrical with the entries on each side. Pascal's triangle will help us expand a binomial. So if you have 2 terms, a binomial, and it's squared, normally we would do a plus b times itself. And you'd FOIL, box method, distribute, whatever your multiplying method, and you'd get 1a squared plus 2ab plus b squared. I'll show you. A times a times b, a times b, and b times b. So here's the 2ab in the middle. Well, this 1, 2, and 1 comes from this line of Pascal's triangle. So now if we do a plus b to the third, I would have to take this resulting trinomial and multiply by a plus b again, and it's a real pain. So this binomial expansion that we're going to do today helps us do binomials to the power of 5 or 6 or so on. So you can see a plus b to the third, the coefficients are 1, 3, 3, 1. A plus b to the fourth, the coefficients are 1, 4, 6, 4, 1. And there's another pattern that's really interesting, is if you look at the exponents, see this 2, we'll start with the squared. That's an a squared, a to the first, and then no a. And then going backwards, there's no b, b to the first, b squared. So like let's jump down here to a plus b to the fifth. You've got a to the fifth, a to the fourth, a to the third, a squared, a to the first, and then no a. And the b's go backwards, no b, b to the first, b squared, b third, b fourth, b fifth. And if you add up the exponents in any term, they should equal 5. So 4 plus 1 is a total of 5. 3 plus 2 is 5. 2 plus 3, still 5. 1 plus 4, 5. And 5 plus 0, 5. So we can use that to expand, we can use Pascal's triangle to expand x minus 3y to the 7th. So first I need another line here. We need 2 more lines because this was squared, third, fourth, fifth, 6. So we're gonna, 1 plus 5 is 6, 15, 20, 15, 6, and 1. All right, so 1 more line is gonna give us the coefficients for the 7th. So 1 plus 6 is 7. 6 plus 15, 21. 15 and 20. And then they're gonna repeat. So here's all our coefficients. Don't write humongous because we're gonna need all this space. So it's gonna be 1 x to the 7th, negative 3y to the 0. I like to hold that there. You don't have to write the 0, but I like to. Plus 7, x to the 6, negative 3y to the 1st. These numbers add up to the total exponent on the binomial, plus the next coefficient. So this became 5, this one becomes 2. Down, up. And then what I'm actually going to do, I'm going to stop writing the exponents for a second because I like to fill them in at the end. That way I don't have to remember my pattern. Okay, x goes 4, 3, 2, 1, none. And the y's are going up 3, 4, 5, 6, 7. We didn't simplify it because we would have to do like negative 3 to the 1st and multiply that coefficient times the 7. I'm just going to leave this one here. We'll have more practice on the next page. Okay. So down here, using the binomial expansion theorem, those coefficients in Pascal's triangle also come from the combinations. Sorry, let me show you that at the top. This is page 19. So if we type 0 combination 0, it's a 1. 1 combination 0 is a 1. And then this entry is a 1. So like, let's go down here to the 4 line. 4, 0, that's a 1. The next entry is a 4, so this is 1, 4. 6, 4, 1. And the 1, 4, 6, 4, 1, if you look back at the Pascal's triangle, 1, 4, 6, 4, 1, it matches. So these combinations get us the coefficients of the binomial expansion. So what do all these symbols mean? This is the coefficient, then it's going to be x to the power of whatever is on the binomial. Then x to the power minus 1. So this is the x exponent is decreasing each time. This symbol is a sigma. In math, that means sum. And we're adding all the terms up. Okay, so we're going to do that for x plus 5, x plus 2 to the 5th. First, I need 5c0 all the way up to 5c5. I like to do that first. So we get 1, 5, 10, 10. Then it's going to repeat 5, 1. So these are all our coefficients. So it's going to be 1 times x2. And then we're going to fill in the exponents at the end. 5, going to fill in the exponents. 10, 10, 5, 1. Oh, I fit it. All right, so now the exponents. The first variable starts at the 5 and then decreases. 4, 3, 2, 1, 0. And the next variable increases. 0, 1, 2, 3, 4, 5. And now we're going to simplify this expanded polynomial. 2 to the 0 is 1, so this first term is x to the 5th. 2 to the 1st is 2. 2 times 5 is 10. 2 squared is 4 times 10. 2 to the 3rd is 8 times the 10. 2 to the 4th is 16 times 5. That I'm not going to do in my head. Oops. 80. And then 2 to the 5th is 32. X to the 0 is 1. 1, 2, 3, 4, 5, 6. And we got 6 terms. 1, 2, 3, 4, 5, 6. Okay, they're all there. We simplified our polynomial. So there's some other cool properties that happen. If I had written the brackets this way, what I should have done is showed you this is 5C0, 5C1, 5C2, 5C3 for the coefficients, 5C4, 5C5. Okay, so here's the other cool property. This 5 and 0, it's the 5 and the 0. Then here, 5 minus 1 is the first exponent of 4, and the 1 goes here. 5 minus 2 is this exponent of 3, and the 2 goes the second. 5 minus 3 is 2, the 3 goes second. 5 minus 4 is 1, and the 4 goes second. And 5 minus 5 is 0, and the 5 goes second. So there's some neat patterns with this theorem. We're going to do this 2 more times, and then you're going to have homework. So the reason I wanted to point out the pattern is because we want y to the 8th. So we know that's going to be some coefficient with 10c something, 2y, and negative 3. So if I want y to the 8th, the 8 has to go here. That means, if we look back at the pattern, remember it was 5 minus 1 is 4 for this coefficient? So 10 minus what is 8? That's 2. And then this second number is the exponent here. So, all right, so let's fill some of this in. 10C2 is 45. 2 to the 8 is 256. Y to the 8th. And negative 3 squared is 9. So the coefficient, we have to multiply all 3 of these numbers together. 9 times 256 times 45. Whoa. 103,680 y to the 8th. So the coefficient is this number. All right, one more. Find the third term. So we know it always starts 4C0. So that's first, second, third. And then our exponent property. 4 minus 2 is 2. And then this 2 goes here. All right, so let's see. 4C2 is 6. 2 squared is 4. 3 squared is 9. So we're going to do 6, 4, and 9 all multiplied. 216. X squared is the third term of that binomial. Okay, so your homework is page 21, numbers 1 through 8. Also, study for the quiz. Your quiz is on counting principle, tree diagrams, permutations, and combinations. Binomial expansion is not on the quiz. That will be on the test after the quiz.